Learning Target 1C, use the remainder theorem to evaluate functions and determine if the factor is a root. So the first problem that we're given is 7a to the fourth plus 23a cubed minus a squared plus 26a plus 5, and we're dividing that by 7a plus 2. Now, when we use synthetic division, which is the easiest way to use the remainder theorem, we have to only use the solution. So with 7a plus 2, we're not in solution form. So the way we do this is we take the opposite of plus 2, which will be minus 2, and we set up our synthetic division problem with that minus 2. Now, when you're using synthetic division, you always have to check to make sure you have a term for every variable. So, for example, this particular problem and the constant is fine. The only one I cannot have is a constant. If I'm missing any of the other terms, I have to put in a 0. This one has all of the terms, so I use the coefficient. Coefficient of 7a to the fourth is 7. Coefficient of 23a cubed is 23. The coefficient of a negative a squared is negative 1. The coefficient of 26a is 26, and the constant is a positive 5. Now, this one is slightly different because I do have this 7 in front of the a. So what I'm going to do is I start by bringing down the first term, which is 7, but because I have the 7 in front of the a, I have to divide that 7 by 7. 7 divided by 7 is 1. Now, like regular synthetic division, I multiply the negative, which gives me a negative 2. I write that under the 23, and I add 23 plus negative 2 for 21. But again, I have to divide by the 7. So divide by the 7. 21 divided by 7 is 3. So I multiply negative 2 times 3. I get negative 6. I add negative 1 plus negative 6 is negative 7. And again, I still have to divide by 7. Have to divide by 7 every time. So that simplifies to a negative 1. I multiply negative 2 times negative 1. That gives me a positive 2. I put that under the 26. I add. That gives me a 28. And again, I have to divide by 7. 28 divided by 7 is 4. I multiply negative 2 times 4 for negative 8. Add, I get negative 3. The negative 3 is my remainder. So I do not have to divide that one by 7. Now, the fact that I do have a remainder of negative 3, therefore 7a plus 2 is not a factor. In order to be a solution, in order for the 7a plus 2 to have been a factor, my remainder would have had to have been 0. So for my next one, determine if the value is a solution. I'm given f of x, which is equal to x cubed plus 7x squared minus 48, and the value of x I'm given is negative 6. So we want to decide, is that a solution? So I set this up for synthetic division using the negative 6 and the synthetic division symbol. I double check to make sure that I do have a placeholder for every term. This one starts with x cubed. It goes down to x squared. Oh, but then it goes to negative 48. It completely misses the x to the first term, so I have to put a 0 in that position. So the coefficient of x cubed is 1. The coefficient of x squared is 7, but I do have to have a 0 for the coefficient of x. I have to have that placeholder, and then I have the negative 48. Now this time I do not have to divide because I do not have a quantity in front of the x with this x equals -6. So I bring down the 1 and I multiply. -6 times 1, put that under the 7 because that is -6, and I add 7 plus -6 is 1. Multiply again. -6 times 1 is -6, and I add 0 plus -6 is -6. Multiply again. -6 times -6 is 36, and one more time I add for a -12. -12 is my remainder. Therefore, x equals -6 is not a root. It's not a solution. It's not a 0. And the other interesting fact is that if I evaluate f at -6, if I substitute -6 into the function f of x, I would actually get -12 as my result. So for this last example, I have f of x equals x squared minus 6x minus 40, and I'm checking to see if x equals 10 is a solution. So the 10, I don't have to divide this time, and I am in root form. So set up my synthetic division. I have an x squared term, an x term, and a constant, so I have all my spaces, all my terms. I have a 1 in front of the x squared, a -6 in front of the x, and a -40 is my constant. I bring down the 1. 10 times 1 is 10. That goes under the -6. I add. -6 plus 10 is 4. Multiply. 10 times 4 is 40. I add. I have 0. My remainder is 0. So yes, x equals 10 is a solution because the remainder is 0. 10 is a solution.